Okay, in this video, we're going to talk about the uniform distribution, which is just a special type of probability density functions, which we've already talked about. So the uniform distribution, also sometimes called the rectangular distribution, is a probability density function that is constant over a range of values and zero elsewhere. So let's look at what this would be. So if I have 0 and I have some starting value a, and some ending value b, if it's constant over those range of values from a to b, then it's going to be the same value. So maybe I'm here at this y value, and that would be a line from a to b because it's constant. And that's what my probability density function would look like. And so that's why it's sometimes called rectangular, because it does make a rectangle. Okay, so what is this value here? And of course, this is f of x or y, and this is x. So we would want to know this value to be able to write the equation of our probability density function. So what you're going to do with this is going to be equal to 1 over b minus a. Okay, because remember the area under a probability density function is 1. So this whole rectangle has an area of 1. And this distance is b minus a. So that length there is b minus a, which you see here. So to find the area of a rectangle, we do length times width. But if I know the area of the rectangle and I divide by the length, then that would give me the width, or in this case, the height. So you need to know how to do this. It's always going to be 1 over b minus a. You have to be able to write the equation for a probability density function. So we would say f of x equals, and we would say 1 over b minus a for a to b, and then it's 0 otherwise. So this is how we would write the probability density function. Okay, so we're going to look at an example, and we're going to talk about a few special formulas that would be beneficial for you to know and understand. Okay, so a junior gymnastics league is open to children who are at least 5 years old but have not yet had their 9th birthday. The age x years of a member is modeled by a uniform distribution. They have to tell you that. Over the range of possible values between 5 and 9. Age is measured in years and decimal parts of a year rather than just completed years. Find, and part 1 says find the probability density function of x. So we would need to do f of x is equal to 1 over b minus a, and this 5 to 9 is our range of values. So we're going to do 9 minus 5. And of course that equals 1/4. So what we would write is we would say f of x is equal to 1/4, just that. Remember, it's constant. For values from 5 to 9, but it does say from 5 to 9, it says at least 5 years old, so we're including that, but have not yet had their 9th birthday, so they're not quite 9, so I didn't put the or equal to under there. Okay, and then 0 otherwise. So this is our probability density function that we're going to use to answer these other questions. Okay, and I'm going to show you both ways, the way we've learned to do it, and then some shortcuts. So let's draw this though. Here's 0. This would be 5. This would be 9. So we would have 6, 7, 8. Okay, and this is going to be 1/4. So we have a line there. And this is what my probability density function looks like. So now we're being asked to find the probability that x is between 6 and 7. And of course, you can set this up as the integral from 6 to 7 of my probability density function right here, of this 1/4 dx. You can do that math exactly. And you can integrate this, which would give you 1/4 x, and you would evaluate that from 6 to 7. And if you do that, you happen to get 1/4. The probability that x is between 6 and 7 is 1/4. How else could we figure that out? Well, if I look at this graph here, this would be 6, 7, 8. And we're trying to find the area in this rectangle here from 6 to 7. And of course, this is 1 unit, and the height is 1/4, so the area for that rectangle would be 1 times 1/4, length times width, which gives us 1/4. And so I could have found it using this graph and not doing it this way, but both ways work, okay? All right, so I wrote this up here so that we could see it. We've already written this. This was from part 1, but now we're being asked to find the expectation or the mean. Okay, and again, we know how to do this. We've done this for other probability density functions, so I can set this up as the integral from 5 to 9. Remember, when we do expectation, we do x times my probability density function from up here, so 1/4 dx. I can do that. I can set it up just like that. And so this is going to give me the integral from 5 to 9 of 1/4 x dx. When I integrate that, I'm going to get 1/8 x squared, and I want to evaluate that from 5 to 9. And when you do that math, you get 7. Okay, but again, here's my picture. 5, 6, 7, 8, 9. We're at 1/4 up here. So since this is constant, it would make sense that the mean is at 7, which is the middle value. So we could have actually done 9 plus 5 divided by 2 to find the midpoint because it is constant. And so, of course, 9 plus 5 is 14, divided by 2 is 7. But again, this way works. You have to be able to write the probability density function, and then you can do it this way, or you can understand the shortcut. Okay, for variance, we can set it up just like we learned. We can say the integral from 5 to 9 of x squared times 1/4, okay, dx. But then remember, we have to subtract our mean or our expectation squared. We have to remember to subtract that. And you can actually do all of this math and get the correct answer. And so if I integrate this, I'm going to get 1/12 x cubed from 5 to 9 minus, we found our mean over here to be 7, so minus 7 squared. And of course, you guys know how to do this math. And when you do that, you get 1.333. And that is going to be my variance, which we've done. But now, is there another way to find variance? In this case, there is, and this would be a formula that you needed to memorize if you want to use the shortcut. So you can actually also say 1/12 times the quantity b minus a squared. And that will give you variance. So 1/12, 9 minus 5 squared is 1/12 times 9 minus 5 is 4 squared. This gives me 16/12, which reduces to 4/3, which is 1.333. Okay, but you would need to memorize this formula for variance. Either way, it's completely up to you, but I wanted you to see it and understand how to do that. Now, we do have one more I want to talk about. Again, here's my probability density function for my uniform distribution. This one asks, what's the percentage of children whose ages are within 1 standard deviation of the mean? Okay, and again, there's kind of 2 ways to do this. I want you to think it through and be able to do it in case you don't have the little rules memorized. So, standard deviation. Remember that standard deviation is the square root of variance. And we found variance on the previous part. So our standard deviation in this case is going to be the square root of that 1.333. And of course, you should be using an entire value. So when you do that math, you store it in your calculator and you use the entire value. And in this case, I get 1.155. So this is my standard deviation. And so when we say within 1 standard deviation of the mean, we mean we want to take the mean, which we found to be 7, and we want to go 1 standard deviation above it, so plus 1.155, and 1 standard deviation below it. So I want to subtract the 1.155. And for this, my value is going to be 5.845. And here, I'm going to get For this one, when I add them, I'm going to get 8.155. And down here, when I do 7 minus this 1.155, I'm going to get 5.845. Okay, so now that I have these two values, and I want to find the percentage between, or that are within one standard deviation of the mean, so the percentage between these two, I can set up an integral from my lowest of those two values to my highest of those two values of my equation, my probability density function. So I can just do that math and get the correct answer. And in this case, when we do that, all of that math, we get 0.5775. And in this case, we're asked for a percentage, so we would say 57.8%. That's the percent of children whose ages are within one standard deviation of the mean. Okay, so another way to look at this is that if I have this 5 to 9, again, with my rectangle here, and the mean was 7, and I want to be one standard deviation, that I'm over here somewhere, and I want to be one standard deviation up, and I'm over here, and so we're saying what percentage is this of this whole area? And again, what I'm really doing is I'm saying I took this 7 and I went my standard deviation 1.155 to the right and 1.155 to the left. So that is really 2 times that 1.155. Okay, so that's how wide this is going to be. And in this case, I need to multiply it by this height here of 1/4. And that's the percentage of my whole. Because my whole area is 1, I don't have to worry about anything else. So I can just do this math right here, and that's going to give me the 57.8%. Okay, so hopefully that makes sense. But if not, you're welcome to do it this way. Okay, and that will work. What you do absolutely have to remember is that for a uniform distribution, our function that we have to write is 1 over b minus a. You have to be able to write that equation so that you can do the rest of the problems. Okay? All right, go back and review what you need to, and we'll work some more in class.